For problem identification, road safety depends on three things. First, how tires grip the road. Second, how rough the surface is. And third, how water drains away. Unfortunately, people often forget about these things when making or fixing roads. If we don't check this properly, cars can easily slide and cause the accidents. Our project wants to fix this problem by finding better ways to check the roads and making them safer for everyone. We have four main goals. First is skid resistance. We want to measure road friction to see how it affects vehicle skiddings. Second is the sand patch test. This is to calculate the road's texture depth so we can understand its friction and how water spreads. Third is outflow meter test. We use this to check how well the road surface drains water. Finally, our overall objective is to look at how all these tests connect so we can suggest practical ways to make roads much safer. The location that we choose is between Block 1 and Block 2 at Faculty of Civil Engineering. First, we test for smooth surface which have fine aggregate. Second, medium surface which contain a mix of fine and coarse aggregate. And third, rough surface which have coarse aggregate.
Apparatus used for this test are portable pendulum skid resistance, scale ruler and brush. Firstly, clean the test surface to remove dirt and loose particles. Second, level the skid resistance tester by adjusting the base until the bubble is centered in the circular level indicator. Next, loosen the locking knob so that the pendulum arm can swing freely. Adjust the tester height so that the slider rubber just touch the surface at 3 reference points. Set the maximum swing indicator to the vertical 0 position. For the dry condition, push the release button to allow the pendulum to swing and record the reading. Repeat for 3 times to get average value. For the wet condition, evenly wet the test surface with water. Then repeat the pendulum release and record the readings. Take 3 readings and calculate the average. After that, repeat step 1 until step 7 in the location 2, which is medium surface. And lastly, repeat step 1 until step 7 again in the location 3, which is smooth surface.
Before starting the lab session, let us quickly review the 5 essential safety precautions. First, check your zero adjustment and inspect the slider condition. Next, verify the slider length and ensure proper leveling of the apparatus. And finally, always remember to account for wet versus dry readings. Follow these 5 steps carefully for accurate results and a safe lab environment. Let's break down the data where we compare surface textures under dry and wet conditions. For the dry surface, we can see a clear upward trend as friction increases, with average values jumping from 64 on smooth to over 102 on rough surfaces. Now, look at the wet conditions. While the upward trend remains as the surface gets rougher, introducing moisture noticeably drops the overall values across every single texture.
For discussion, skid resistance significantly increases as road texture transition from smooth to rough. When introducing water, drastically reduce this value across road texture. For conclusion, pavement texture and moisture level directly dictate skid resistance. Rougher surface provide superior friction, but wet conditions severely compromise safety, reversing the need for high texture surface to minimize hydroplaning.
The apparatus used for this test are sand, brush cylinder, roller, brush and sand spreader. First, for the rough surface, the test surface is cleaned and dried before the testing. Second, a 50 ml of sand is poured onto the pavement surface. After that, the sand is sprayed evenly in a circular motion until surface voids are filled. Next, the diameter of the sand patch is measured by using a ruler. And don't forget to record all the data. Repeat all the steps in the second location, which is medium surface. And repeat all the steps again in the third location, which is smooth surface.
Before and after conducting the experiment, we must follow the safety precaution. First, please sand the equipment cautiously. Next, please remove sand before and after the test. Third, we have to clean and dry the surface before and after conducting the test. Fourth, please wear appropriate PPE, which is reflector and safety boot. Lastly, please be aware of your surrounding while conducting the experiment. After we're done conducting the test, now we will proceed to data analysis. We have conduct 3 different types of surface within the experiment. First is rough surface. Next is medium and smooth. The volume of sand that we use is 50 ml for each surface. So the average sand patch that we got for rough surface is 206.25 mm, medium 217.5 mm, and the smooth surface is 252.5 mm. The highest is the smooth surface diameter. And the average texture depth that we got from each surface is rough 1.5 mm, medium 1.41 mm, smooth 1.55 mm. The highest average texture depth is smooth surface. After we conduct the experiment, now we have to discuss and conclude the result. Discussion is the sand patch test yield average macrotexture depth ranging from 1.41 mm to 1.55 mm, fluctuating based on the specific condition of the surface. The rougher the surface naturally produce the highest texture depth, ensuring superior drainage and skid resistance, while the medium and smooth surface still remain safely within the acceptable regulatory limit. In conclusion, all the tested road surface fully comply with established JKR and business standard requirement. Furthermore, the findings highlight the rougher pavement provide superior safety performance and optimal condition capability, particularly under challenging road conditions.
Apparatus used for this test are water, timer, and outflow meter. The weight is locked to ensure stability of the outflow meter. So first, outflow meter is placed at first location, which is rough surface. Fill the water into the outflow meter until 100 ml at first carefully to avoid spillage. Make sure eyes are perpendicular to the meter to avoid error. Timer is set. When ready, the valve is open and timer is started at the same time. Timer then stop when water flow is finished and recorded. The same procedure is done at water level 200 ml. And the same procedure at 300 ml and 400 ml volume of water. Same procedure is repeated at location 2, which is medium surface, and at location 3 with smooth surface. And don't forget to record all the data.
For the safety precaution, first, we will ensure apparatus stability. Second, we will prevent water spillage. Third, we maintain proper stance to avoid parallax error. Fourth, we will wear appropriate footwear. And lastly, site safety awareness.
Next is the data analysis for the outflow meter test. We use a fixed water volume of 100 cubic millimeters and measured the drainage time. The outflow rate was then calculated using Q equals volume divided by time. At location 1, the first reading gave an outflow rate of 27.78 mm3 per second, and the average outflow rate was 38.87 mm3 per second. The higher outflow indicates better drainage, reducing water accumulation, and the risk of hydroplaning. From the outflow meter test, we found that rougher road surfaces drain water much faster than smoother surfaces, and all results comply with JKR safety standard. Better drainage improved tire grip and reduced the risk of hydroplaning, especially during wet conditions. Overall, combining the result from the skid resistance, sand patch, and outflow meter test, we conclude that rough pavement provides the best road safety performance due to its higher texture, faster drainage, and better skid resistance. Therefore, maintaining adequate pavement texture is essential for safer roads, particularly in wet weathers.